Okay, so today is the class for the past papers of vectors topic that we finished, and we discussed a few past papers in the last class as well. And for today in this class as well, I want to discuss a few more because we are soon going to have a test as well of the topics we have done before, the vectors especially, and the forces and equilibrium that we did. So that is also a part of the test coming in very soon. So prepare, brace yourselves. So this is the question. Let's see. They have first of all given you a ship moves, a ship A moves with a constant velocity. So they have given you the velocity vector of A. So you write it down. Velocity vector of A, it is equals to 3 minus 10 kilometer per hour. Then at time t seconds, the position vector of A is R. So they are giving you time t seconds. The new position vector of A is R. So we know the new position vector they're talking about. They're calling it R position vector. It is equals to the old position vector. We don't know the old position vector. Yes, we know. Here it is. At time 0, A is at the point at the position vector this one. So the old position vector is 13.5 plus the time times the velocity vector, which is 3 minus 10. So find R in terms of t. You have found it. So 2 marks. Easy 2 marks. That's what they ask you. Find R. R is the new position vector, the general position vector of the ship A after time t seconds, time t hours. So the old position vector plus velocity times time will give you the displacement. So how much it has displaced, you add them up, you will get the new position vector. Then they have given you another ship B moves with the constant velocity. So they have given you velocity vector of B as well. It is 15, 14. And then at time t0, B is at the point. Okay. So original position vector of B is given to you. OB, original, old, you can say. It is given to you. Original position vector is 3 minus 5. And then show that at time t hours, AB is this. And then I told you, AB is not a position vector. It is a displacement vector. And we can write it down in terms of position vector. A position vector of B minus position vector of A. This is how you open up any displacement vector in terms of position vectors. So OB, the general, the new OB and the new OA position vectors. So OB new vector would be, new position vector would be the old one, 3 minus 5 plus times the velocity vector of B, 15, 14, minus the position vector of A, 13, 5 plus times 3 minus 10. And when you expand this, simplify this. So 3 plus 15t minus 5 plus 14t minus 13 plus 3t and 5 minus 10t. And when you simplify, 3 minus 13 will be 10 and 15 minus 3t will be 12t. And minus 5 will be 0. Minus 5, 14t minus 10t. So plus 24t. This is your AB vector, generalized. And if you see, I think we have got it wrong. Oh, no, sorry. Minus 5 will be minus 10. This will be minus 10. Minus 5 and then minus 5. Sorry, minus 5 would be minus 10. So now we have got it right. And if you write it in the IJ format, it would be simply 10. Wait a minute, wait. Yes, I'm making silly mistakes. 3 minus 13. 3 minus 13 will be minus 10. So this would be 12t minus 10 iota. Sorry, not iota. I plus 24t minus 10 j. This is what they asked you. And this is the position vector. Given that the two ships do not change course, find the shortest distance between the two ships. Okay, now this is a very, very good question. How will you get the shortest distance between the two ships? Any ideas? Think about it.
I'm not really sure.
Think. Now there is a little bit of quadratic chapter or a little bit of differentiation that may be used over here, but think.
The magnitude.
Mm-hmm. Magnitude will be the distance between them. Magnitude. And you know how you get the magnitude? It would be square root of
Yeah,
this thing squared plus 24t minus 10 square. This is the magnitude. And now
we simplify it.
mm-hmm. So square root. I'm writing a square over here and I'm removing the square root over here. Okay. I would like to write again and again and again. So 12t square will be 144t square minus 20 minus 240t plus 100. 24t square will be, how much is the square of 24? I forgot it. 576 minus 480t plus 100. 144t square plus 576t square. 720 t square minus 240 minus 480. Oh, sorry. So this is minus 720 t and 100 plus 100 is 200. Now what?
We use differentiation.
Any other way? That's what I have told you. What would you do after you differentiate? Because it is differentiation is P1, so you have not done yet P1, you're directly doing M1.
We use a quadratic formula.
And then you will find the roots. What would you do of the quadratic formula?
You find the
So P,
value of t and substitute it back
what?
in.
What? No. If you would solve it for 0 and then find the quadratic formula, use the quadratic formula. So that would just give you the time when the distance between them is 0, right? AB is the distance. So if you would equate them to 0 and use the quadratic formula to get the roots for t, the t values would be the ones where your distance between them it is 0. You don't want that. You want the shortest value. You want the shortest value of this thing. Now you can see this is a quadratic equation. And quadratic equation which has a positive, right? Your coefficient. This is your a. The coefficient of the square t square, the variable square. If it is positive, then this is a smiley face like this. So there would be a minimum point, and the y value of the minimum point will be the lowest value for the distance between AB, isn't it?
Yeah.
So what would you do? You would need to find the turning point of this quadratic. And how do you find a turning point of a quadratic equation? So you can find a turning point using differentiation. You can either do it using differentiation or using completing the square form. or this format, ax minus h whole square plus k. Do you know any of these?
Yeah, I know both of them.
So what would be your h comma k? Your h comma k is the turning point. How do you get the h comma k, h and k value? Can you do that for me?
Yeah, sure.
Okay, do it. I'm waiting. Let's see if you can recall this or not. What is it?
720 bracket t minus half bracket square plus 20.
Plus 20.
Yeah.
Are you sure 20? Let's see. Yes, 20. So this means that the turning point is 0.5 comma 20. So this means the lowest value of this square is 20. So the lowest AB distance is square root 20. Do you understand?
Yeah.
Interesting. Find the bearing of ship B from A when the ships are closest. So we want to find the bearing. So if we may
Wait,
find
sir,
this.
for the previous question we were just doing, is root 20 the answer?
Yes, root 20 is the answer. Yes. For the part D now, find the bearing of ship B from A when the ships are closest. So the time when they are closest, it is 0.5. So we can use this 0.5 to get the vector between AB. So 12 times 0.5 minus 2 will be 6 minus 10 would be minus 4. And 24 times 0.5 is 12. 12 minus 10 is 2. So AB vector is now this, right? So this means if you want to go from A to B, you would have to move minus 4 in X and plus 2 in Y. If you want to go from A to the point B, right?
Right.
And then they're asking you to find the bearing of ship B from A. B from A means that your north will be at A. So they're asking you to get this angle. So first you can get this angle theta, which would be tan inverse of opposite upon adjacent. And then you will add the bearing for the bearing it would be this angle plus 270, which will be tan inverse 0.5 plus 270. It is 296.6 degrees. Okay.
Okay.
Understood, right? Everything cool?
Yeah.
Okay. A particle. I think we did this one or no, this is something else. A particle P of mass 2 kg moves under the action of two forces. Find the magnitude of the acceleration. So F is equals to ma. And the sum of the forces. The resultant force is equals to ma. So the sum of the forces, you can simply add them. So 2, 3 plus 4 minus 5. It is equals to ma. Mass is 2 kg and acceleration. So 6 and minus 2 multiplied by 1 upon 2 is equals to a. So 3 and minus 1 is your acceleration. And they're asking you to find the magnitude. So magnitude, acceleration magnitude is square root 3 square plus 1 square, which will be equal to 9. 9 plus 1, 10 under root 10 meter per second square. Then at time t0, t has a velocity. So time t0, velocity of p is given to you, minus u and u, where u is a positive number, okay? When time is capital T, the velocity is 10 2. Find the value of capital T. Find the value of u. Okay. We know the acceleration. So
Yeah.
we can do the new velocity. Velocity new is equal to velocity old plus acceleration times time. So the new velocity is given to us 10 2. Old velocity is minus u into u. Sorry, minus u plus acceleration vector we know 3 minus 1 times time. And now you can form simultaneous equation. So 10 is equals to minus u plus 3t and 2 is equals to u minus t. And if you add both the equations, this would cancel out. So 12 is equals to 2t. So your time is coming out as 6. And if your time is 6, so 2 is equals to u minus 6. So u will come out as 8. That's it. It was a simple one. And they're giving
It
you
is.
10 marks for this. A particle is acted upon by two forces F and G. The F has a magnitude of 8 and X in the direction of a bearing of, okay. The G has a magnitude of 10 and X south. Given that R, find the magnitude of R. So F is a force, X in the direction 240. 240 would be somewhere over here. If this is your north, no, 240 would be in the third quadrant. In this direction somewhere. Close to 270. This is your force F, 8 Newton. And the other one has 10 Newton south. So 10 Newton south. 10 Newton south. R is F plus G. Find the magnitude of R. So the G force, it is equals to only minus, sorry, this would be 0I minus 10J newtons. Because there is no component, it is vertically down. So no horizontal component. And for F, we would need to break it down to components. So this is the angle. This would be 270 minus 240 will become 30. So this one, the horizontal would be cos 8 cos 30. And this one would be 8 sine 30. And the directions also important. So the x component will be minus 8 cos 30 I and minus 8 sine 30 J Newton. And then they're asking you to find the magnitude of R. So R is the sum of both of these. So R will become minus 8 cos 30 and minus 10 minus 8 sine 30. And then you would find the magnitude. We have done both of them in the same part, I think. 7 marks. So square root minus 8 cos 30 square plus minus 10 minus 8 sine 30 square. So 15.62 Newton. And then they're also asking you to find the and bearings. So this is in again the third quadrant. Oh, it would be somewhere over here. So we know we can find this angle, theta, and it would be tan inverse of the horizontal component, which is 8 cos 30 upon the vertical component 10 plus 8 sin 30. So tan inverse of 8 cos 30 upon 10 plus 8 sin 30. 26.3. And you will add 180. So the bearing is plus 180. So 206.3 is your answer. Okay?
Question, why did we add 180?
Because bearing is always from the north, right?
Oh, okay.
Angle, so 180 plus this angle.
Okay.
So 7 marks. Let's check the answers as well. Question number 5. January 21. Question number 5. 15.62 and 206. Nearest degree, yes. We lost 1 mark because of,
Oh, we didn't round it.
yes, giving your answer as a bearing to the nearest degree. So 206. Looks like a good question. Not an easy one. Let's see. Okay. Paris.
Okay.
So the answer to the last question that you tried are these. The first part is under square root 13. Second part 124 bearing. And for part C, the time is 3 and the position vector is 9,4. Okay, and you got it right, so that's good to know. And now you can try this one. That's the last one for today. This is January 15, 2000. January 2015. And question number 1. Okay, you can try this and let me know. Okay, I'm stopping the
Okay.
recording now.